Okay, so these are some facts about parallelograms as we currently know. And in fact, we can go ahead and, well, we're going to come to these conclusions as to what these next three are. Actually, you're going to come up with those. You're going to figure them out yourselves. So, if we're ready, let's go through it. So, I'm going to take the parallelogram, and you can copy this down, but I want you to seriously look at this, because there's something that's going to happen that I want you to notice. Oh, sorry, I'm not going to do that one. I'm going to do this. Take a look at that vertex right there. Now, everyone has to keep their eyes on it because something's about to happen. It is. So what does that tell us about parallelograms in general? What are the same? Which angles? I got lots of angles in there. Angles that are opposite to each other. And in fact, wait for it, wait for it. Ta-da! Oh, I know. Well, yeah. Hold your applause, please. Okay, so it's true for any pair of opposite angles, okay? So we can go ahead and add this. Okay. So opposite angles are angles that don't have anything, that don't share any sides with each other. Okay, the ones that are on the opposite side of the triangle from you. Okay, opposite angles are congruent. Okay. We cool? All right. Now let's try something else. Facts. So, actually, I'm going to go ahead, clone that for a second, come down here, clone it again. Now, take a look. We already saw that trick, but watch. What does that tell you? They make a line, right? Make a straight line. What's the name of that pair? Say it again. You were right. I heard it. I heard it from that table. Supplementary. But what do you call a pair of angles that are supplementary and sit next to each other? Like those two. Starts with a, well, it's a pair of angles, some kind of pair. Pair of angles that makes a line. What do you call it? Mm-hmm. It's a really original name. Pair. Wow, remember? Come on, guys. Linear pair. All right, so if I have two angles that are next to each other, what's a mathematical word that we use for angles that are next to each other? Say it. Adjacent. So we have the following. And let's go back here and add that in here. So adjacent angles are supplementary. All right, we all got a copy? So, we haven't done the last one yet. So, we have we also have so adjacent are next door, opposites are on the opposite sides of the shape of the parallelogram. Okay. So let's see if we've kind of put this into our heads a little bit. Congruent or supplementary? Just say it out loud. What do you got? These two. Ladies and gentlemen, I want to hear it. These two are supplementary. I've only got one person in the guys, get vocal here. Just vocal. There we go. Well, yes, but it's. What are these? Congruent. Okay, do we see how these are put together, right? Which ones are supplementary, which ones are congruent? Congruent. What about those blanks? Those are congruent and parallel, right? Okay. And finally, last one. What are they? Congruent. All right, good. So now I'm going to try and make things a little bit weird, a little bit more difficult. Actually, no, wait, hold on. See these two? These add up to how much? These two add up to 180, don't they? Right? And these two over on the left also those also add up to 180, don't they? Right? So the ones on the right add up to 180, the ones on the left add up to 180, the ones up top add up to 180, and the ones on the bottom add up to 180. But we have two pairs, however you want to do it. If we think left, right, or we think up, down, we have two pairs of angles that add up to 180. So if I added up all four of these, how much would they add up to? 360 degrees, right? Okay, so that's our last fact. And this is a fact of all quadrilaterals. Remember when we did the Venn diagram the other day? There were, if you're in one, then you're in all the layers below it, right? Well, the biggest layer that we had was the bottom layer, and that was the quadrilateral, four-sided objects. four-sided objects, all of their angles add up to 360 degrees. So since parallelograms are in that group, the big group, they have all of those properties. And that we just saw is that 360 degrees. Okay, and let's take that idea about the Venn diagram. Remember, in that Venn diagram, there were layers that were smaller and inside parallelogram. And what were the shapes that were inside parallelogram? Remember pull out your notes from yesterday. It was only yesterday. You didn't get amnesia overnight. What? A rhombus is one of them. A square. Trapezoid was not in parallelogram. No, we have rectangle, square, and rhombus. Those are all, a square, rhombus, and a parallelogram are examples of parallelograms. Which means, this is important, you should listen to this, squares, rectangles, and rhombi, since they are parallelograms, they have all of these properties too. Okay? They have other properties also, like for example, a rectangle has 90-degree angles in it, and a rhombus, all sides equal. There are more properties when you get smaller and smaller and smaller inside that Venn diagram. But the things that are inside the Venn diagram have all the properties of the things outside of it. Okay, layer upon layer. Does that make sense? All right? We see where we're going? Okay? Good. Now, I'm going to try and mess you up. It's not going to work because you guys are too slick for this, but I'm going to try it anyway. Take a look at those three angles for a minute. So I'm drawing one diagonal and I'm pointing out three of the angles. Okay? Let's think about those for a minute. This one over here that's been split apart, this one and this one, these two angles, those two angles added together make that whole corner, don't they? Right? And if we kind of just said, all right, let's just put all this aside for a minute, this and that, what are those? Are they congruent or supplementary? Those are supplementary. So if those two blue circles added up to that whole angle, what can I say about all three blue circles? What would happen if I added up all three blue circles? Just like before, adjacent angles are congruent. Sorry, adjacent angles are supplementary, so all three of these angles, if I added them up, would add up to 180 degrees. And in fact, we have another way of doing this too. Ladies, pay attention. No, you're not. You're talking. No, you're talking. You might be talking about this subject, but you're not paying attention. So please pay attention and then talk about this subject. Okay. These are parallel, aren't they? Right. So that means that angle and that angle are special angle pair. Those are congruent. And in fact, if we go back to our blue circles for just a minute, whoa, pretty big. This angle right there is the same as that angle. And all three of those angles together make a triangle, right? And the sum of the angles of a triangle is how much? 180. So all of these angles are all related to one another. A lot of things are parallel, a lot of things are congruent, a lot of things are supplementary. Okay? So you guys are going to get thrown on the boards. There are two sets of slips to do today. Okay? One of them does not involve diagonals. The next one after that does involve diagonals. And then you have a homework assignment after that. Okay? So yeah, homework assignment. Got to practice, man. Got to practice. SOLs are coming up right around the corner. All right. If we're good on this, I'm going to throw you up on the boards. And this episode of the Ronco Show has been brought to you by alternate interior angles and supplementary angles.